In this episode of the Pontiac 326, we are going over all the details involved in installing a piston in an engine, from ring gap to bearing clearance to pressing in a rod and some other details. So stay tuned and we'll get it covered. Alright, so I am doing the ring gap thing right now. I figured I'd better share this with you guys. It's obviously an important thing of building a motor. I had to take the rods, go get the wrist pins pressed in. So these are a press, I should probably go this way. These are a press fit wrist pin where the wrist pin is pressed into the connecting rod here. So what they do is they have a certain jig that they set up to where the wrist pin will bottom out in a certain spot. And then they heat up the connecting rod, this end of it, and then they take the wrist pin, having it set in here, they take the connecting rod, set it down, put it up against the back, then they push the wrist pin in until it bottoms out against their little jig that they have. And then they wait for the rod to cool enough to lock up to the wrist pin, and then that pin is installed. I do not have the stuff to do that necessarily. I don't have the jig. I could easily come up with something, but I'm not going to when the machine shop does it for me. So there's how that's done. Now the piston rings themselves, the oil control ring, I check them just because, good measure I guess, but the ring end gap on those, just to make sure that they're not going to bind. Almost every engine I've ever done, they always have an insane amount of extra room. I had one that was a little bit tight, so I actually opened it up, which I thought was odd. I don't know, maybe they sent me the wrong rings or what, but I don't know, that was an odd situation. This one, however, it is going rather smooth. So, aside from when I went to the shop, I accidentally left a ring over there, dang it. But other than that, it's going relatively smooth. So, I did all the top rings. They're all set at 16 thousandths. That's what they came out of the box. They were like 15.5 to 16 thousandths gap. And that's exactly what I want. I mean, this is not a performance motor. It doesn't need a ton of ring gap. It's going to work perfectly fine that way. So that's where it's going to stay. And I'm going to go ahead and this is the second ring. So I have all the second rings in there. This second ring that's on here was the only one that gapped out okay. The rest of them are a little bit too tight. They're at 15 thousandths. And the second ring, you always want a little bit more ring gap than the top ring. That way you don't end up with a ring flutter situation. So what I'm going to do now is go ahead and prepare to gap this ring. Now when I center these rings to check the gap, I use a piston with a ring on it. I set the piston in the hole like this and make sure that the ring isn't one direction or the other. You know, I try and center it as best I can. And then I carefully push down until it bottoms out on the ring. Once it bottoms out on the ring, you can pull this out. And now you know that this ring is in there centered. Now I take my feeler gauge, which is a 15 thousandths right now, set it in there, and it's still a little bit tight, so I have to file this ring a little bit more. And since it's close, I mean, if I get 16 or 17 thousandths, that'll be enough. I don't need the exact same as the top ring. What I need is the exact same or a little bit more. I don't want to go too much more, just a little bit more, and it makes for a really nice running engine. So pull that out nice and even. Then I will take and file this and do it again until I get the fit to fit correctly. We will come back as soon as I get all these rings set, and we will start installing pistons, and I'll show you how to do that. Okay, so you can see on the right side of the screen there, those little pits and stuff that are all up in there. Those are from that side being welded, so that must have had a spun bearing right there. The other side is nice and smooth and polished the way it should be. Those pits are not going to actually have any effect on anything because these pits have been polished over, so all those are just little holes. They're little dips. In fact, what it might actually do, which would be kind of cool, is retain a little bit more oil in there for when you start it up again. I don't know, maybe. Weird theory. I don't know. May or may not help. But there's little pits there, a little less surface area, but again, it's not a race motor. Who really cares? It's going to work fine. So I'm going to go ahead, put this back up, and let's go get that piston installed. Flip this guy. Ooh! I see the nuts. I almost dropped the cap. Almost dropped the cap. I forgot I said it there. Alright. First thing we got to do is get this guy prepared to slide in the cylinder. So we have driver side, passenger side, driver side. Oh wait, oh this is, oh, I was wrong. Cylinder 1's over here. Well, this motor's ass backwards. Okay, so the front cylinder is always cylinder 1. Usually GM products, this is flipped. So cylinder 1 would be here, it'd be 1, 3, 5, 7, and then 2, 4, 6, 8 over there. Well, this is backwards. This cylinder 1 is actually right here. That one is the front cylinder. So this is going to be 1, 3, 5. So that's kind of cool. But I did label it. Now I question myself. Did I label it? How did I label it? Did I notice that right away or not? I'm willing to bet I did, but still, I gotta take that into consideration. I'm gonna look at how everything lines up. I am gonna be able to tell because of this offset rod. What'll happen is if it's in the wrong hole, the gap between here, right? So you can see how this thing slides back and forth. It'll be crooked if it's in the wrong hole. So that's how I'm gonna have to tell. Other than that, there's no real way for me to be able to tell. So I'm going to go ahead, slide it in cylinder 5 here, see if I had the right idea when I did it in the first place. But we have to lubricate cylinder number 5, and we have to lubricate the piston ring compressor. I have my special homemade assembly grease stuff, oil stuff here. It's like a concoction of a few different things. All I do, you could just use regular motor oil too, but this is just kind of my own little homemade concoction. I put a little bit in there, and I take a rag. I go ahead and wipe the inside of this down. That way I got a nice layer on there, and then I'm going to do the same thing for the cylinder. Make sure I get a nice layer of lubricant on the cylinder. And when I'm doing this, it's actually going to clean off any debris, any dust that's collected in that cylinder too. Because no matter how hard you try, dust and debris always collects inside these motors anyway. You can see there's a little bit of dirt and debris. It's kind of got a silver coating to it. That's the metallic from the side of the cylinder wall. So after you're done honing a cylinder, it has like micro mountains inside. They're just little peaks and valleys and everything else. And what that's doing is it's grabbing whatever's stuck inside the valley and leaving it on the rag. No matter how many times you do that, you're just going to keep getting it off of there until you do it so much you're blue in the face, and then finally it'll come clean. It's not really worth cleaning it out that much because the moment that you run the motor, you fire up the motor, it's going to knock off all the peaks on that cylinder wall, and then you're just going to have a bunch of that same dust in there again anyway. That's why there's a break-in period on motors, because you're knocking off all the peaks and high spots from the machining work and breaking in the rings to the cylinder walls, etc., etc., etc. So there's that. Let's go ahead, slide this guy in here. My tool goes in that end, so I have to put this way. Ring position, that's an important thing I want to talk about quick. So we have the oil ring here. Okay, so I take that little gap of the center ring here, and I line it up with either over here or over here. And then the oil scraper part of the ring, I take that and I will offset it from the wrist pin a little bit one direction, and then I will do the other one just as well, offset on the opposite end. And then the second and top ring. Now in performance motors, I will pay attention to where this gap is on the top ring. I want the gap towards the intake side. That way it doesn't have as high a chance of getting too hot and causing an issue, assuming that it stays in its position. I've noticed a lot of times they do move around and they don't stay in their position, but at least it gives it a fighting chance at first when there's a lot of blow-by because nothing's quite broken in. But what I do on these mild ones is I just go ahead and just set them anywhere opposite of each other, offset of the center here by just a little bit. So I have the top ring here, I have the bottom ring lined up here as far as the gap, and now I'm going to go ahead and put the ring compressor on there. Now these ring compressors can be quite tricky. You need to make sure you leave it above the bottom of the skirt, that way you have something to start in the cylinder. And then of course you need to make sure you get the front of the piston in the right direction. My F is right here, so I know this is the front. I'm going to go ahead and very carefully slide this in here. Now these things are tricky because if you don't keep the ring compressor down on the top of the block, what will happen is you'll have the ring pop out on the side, and you could, if it's an oil ring, you could very easily damage it. So speed is good, but too much speed can cause damage when it comes to pushing that piston down through this tool. So watch me go ahead and tighten or put this into place. Now the first thing I'm going to do here is I'm going to take this little rubber mallet. I'm holding down on the ring compressor as well as tapping down on it. Now I'm going to put my hand, so I'm pushing down on this ring compressor while I'm holding the hammer to keep it guided. And I'm also tightening down the engine stand so that this is pretty much vertical as far as the cylinder goes. That way that rod stays centered and it doesn't slide against the cylinder. So here we are. We're going to hold this down, put this on here, and then we're going to tap this a little bit. And once I know I'm close to that oil ring, I'm going to give it a decent size hit, hopefully enough so that it'll speed past those rings. But before I do that, I take and I look over the ring compressor to make sure it's actually bottomed out. Looks like it is. So now I'm going to go ahead and I'm make sure I maintain pressure against it. Oh, it stopped. Okay? Being it stopped for a reason. So I got to take a look around. Doesn't look like any ring is there. Looks like it's past all of them. I'm going to try one more time, maybe a little lighter. Oh yeah, there it goes. Okay. So it worked fine. It just I don't know if it snagged maybe where this goofy mark is. So maybe I'll have to pay attention to that with the ring location. Try and avoid this area because that'll make the ring pop out and then it'll have to slide past it. In fact, I'd probably scratch it if it did. Well, it wasn't that one. Well, it doesn't look like it hit that. I don't know. Looks fine to me. So let's go ahead and flip this guy over now. Now you can see the bolt or the rubber hose here has guided it perfectly. It's sitting right where I want it to sit. So I'm going to go ahead and push this up. Okay, now I do not have a bearing on there yet. But that's okay because I'm just trying to judge things right now. So what I need to do is push this thing so it can lay flat on the side of this grind mark here. And then look, okay, so this is the wrong hole. When I labeled number 5, I must have been thinking as a normal engine sits. So I need to try and put it on that cylinder over there and then see what happens. I'll go ahead and show you guys what I'm seeing here. So if you look down there, you can see the offset section, how it's offset more than one direction than the other. And that's because it's not in the right hole. So I'm going to go ahead and move this thing and see if the center goes into a better spot. And you guys will be right back. Alright, I flopped that piston in the engine here and I'm going to show you what I have found. So as you can see, the piston is nice and centered. I have it up against, well, as best as I can here. Try and move it over there. There, I'm holding it against it. And you can see it's much better centered on the piston now. So that goes to prove. Oh, I was wrong. I was wrong. The rod on this end is not any better. In fact, it's even worse as I'm looking at it now. I don't know if I had it tilted a second ago, but I thought I had it on the right one, so I went ahead and put the bearing in. And now that I see what I see, I know that this one is the incorrect side, and I did have the number 5 on the right number 5 over here. So I have to go ahead and flop the piston back. And I'll show you why this is wrong and show you that bearing chamfer thing I was talking about. I wish I would have put the bearing in when it was on the other side. I would have knew right away. So I'm going to go ahead and show you that. Okay, so here it is. Here's the rod installed. You can see it's off-centered still. Now, perhaps this motor's a little bit crude and it stays off-centered on the other side, but even so, you know, even if it's off-centered, it's not going to make or break the motor's running ability. So the one thing I want to show you guys is right here. You see that bearing right there? Now if you look, right on the edge there, right over here, you can see it's against the chamfer. Now if you look at this side, over here, there's a hollow gap there. And that, once this is pushed over to this side, when it's in that hole, it will cause that gap to make up for the little bit of a chamfer, so the bearing is not against the chamfer. And that is a huge mistake that people will make. They will put the wrong rod bearing, upper or lower if there's a difference. This one does not have a difference, on the wrong side, and then it will get chewed away because of that chamfer and spin a rod bearing like what happened over on this side where those divots are. So I'm going to go ahead, flip the piston over to this side, and then you guys will be right back, and we will talk about a little bit of bearing application and checking. Alright, the piston is switched. It looks better now that I can see everything, but it does sit offset. So I'll bring you guys over here and we're going to take a glance at that, and then I'm going to show you where I'm sitting with checking the clearance. So here it is. This is the connecting rod bearing in, and you can see the gap there where the chamfer area is. That's what you want to see. That is a safe way to have it set up. And then you can see I have the Plastigage sitting right here, a decent amount of width. That is to make sure that nothing is crooked, even though it shouldn't be crooked. You know, crooked is my funny way of saying crooked, by the way. So we have that in place. Now here is the bearing surface. You want to try not to get any fingerprints on there, and you got to clean the front and back of the bearings while applying these. I just figured I'd make note of that. That way it's dry and clean for the Plastigage. Here is the rod. See how it's not quite centered. It is offset a little bit. So it's interesting that it doesn't sit centered, at least not quite. See that little bubble off on the left there? That's actually a bubble. That's not dirt or debris, for any of you who might be questioning that. There we go, popped it. That was just a bubble. I don't know how well the camera could pick that up, so I figured I'd make note of that. So there you have it, that's in place. Now, what I have to do is go ahead and set this down on here, and I want to make sure that I have the bearing notch on the correct end so that this cap is in the correct position, and I can verify that also by looking at where the bearing is off-centered. It's off-centered that way, so if I flip it this way, the bearing is going to be off-centered that way, and that's what we want to avoid the chamfer. So I'm going to go ahead and throw this right on here. Now, I do not want to, there we go, it pretty much went right into place. That was nice. I do not want to tighten these down because I do not have any kind of lube on them right now. I have to find, there they are. Grab the nuts, and I want to put just a little drop of oil on these threads. Just going to snug these up lightly by hand first. I know they get torqued to 40 to 45 foot-pounds on this particular engine. It's actually got a range, because back then they weren't near as critical. So being it's got a range, I'm going to go to the lower end of the range for the sake of checking bearing clearance, and then I will go middle range for the sake of actually torquing these down. I'm going to be real easy on this because I want to try not to move anything and mess up my Plastigage. Move slow, nice slow movements, holding on the socket to try and keep the crank from turning at any point. I'm going to go ahead and slowly loosen this up. Now I did feel it twist a little bit, so I expect a little bit of distortion on the Plastigage. It may have squished it a little funny. I'm going to have to pay close attention to when I'm checking it to make sure that I get a fairly accurate reading off of it. Again, nice slow, easy movements. Pull this guy off of here. Alright, it looks very even. There's a little bit of distortion on one side, but I will take an average off of it. Okay, so you can see the Plastigage right there. I'm going to go ahead and show you a little indication of what it's doing. So here is the 2000s mark. If I go over here, it's about 2000s, but if I go over here, it's wider than 2000s, but it's almost as wide as 1.5, so about 1.7, no, 1.8 or 9 there. Well, there wouldn't be 1 point, it'd be 0.0019, maybe, right? So it's pretty much 2000s. I mean, maybe just a little under 2000s of gap. So that's where that guy sits. That is a very decent clearance for an old motor like this. And being the rods are actually round now, that will outlast A lot more so than the last motor. The last time the guy did the motor, he apparently did not check the rods for being out of round. They were way out of round, so much so that he had to cut the rod caps in order to get enough clearance, because you have to cut the rod caps to shrink the diameter of the rod and then run a hone on the inside of that when it's torqued to make sure you get the proper size circle and get a proper circle. Because over time what happens with these rods is they elongate. As the motor's going up and down, or the piston's going up and down, it will actually elongate the rods. You'll get a tighter side clearance than the actual pressure surface clearance, and it causes the bearings to wear out prematurely. So these are nice and round now, and with that clearance I'm very happy. I will go ahead, lubricate this one quick after I clean it, which I showed you guys earlier with the WD-40. Well, I hope this episode was helpful for you, and if it was, be sure to like, share, subscribe. If it wasn't, be sure to hit the thumbs down button. I really don't care what you do, but if you've watched it this long, most likely you enjoyed it, so there is that. And thanks for watching, and I hope to see you on the next episode of this Pontiac 326 build.